Here is my revision of the binary system and how to calculate binary or do conversions. And I'm calling it bits out of bytes. First, the key is to understand that 1 bit is the smallest piece of data possible, because really computers are a series of circuits that connect switches. These switches are either on or off, on being 1, off being 0. Now, early computers ran on what's called an 8-bit system. That means that they had 8 parallel switches at any one point, and that became 1 byte. So 8 bits equals 1 byte. 1024 bytes equals 1 kilobyte, and so on and so on and so on. Now, there is a bit of contention over the idea that it is now 1000 bytes, 1000 kilobytes, 1000 megabytes. However, the reality of the circuit system in computers is that they are still binary systems, and they still use switches that are base 2 in the way that they treat the on or off or binary number system. So it's more a commercial clarification for consumers, so that when they go and buy a 4 gigabyte hard drive or 400 gigabyte hard drive these days, they believe that they've got 400,000 megabytes. But the reality is the circuitry doesn't work that way. So whenever you go into your drives, you'll notice that you never get that clean rounding off in decimal. So it's a bit of a commercial advertising venture there. Now, converting binary to decimal, because in reality humans work in decimal, so we count 1 to 10 and we go up in tens. However, the computers work in binary, and the way that we count binary is with the ones and zeros in the sequence of switches. So this is my example of my parallel 8 switches that are on and off. So 1 is 1, so the top row is my decimal, the bottom row is my binary. 1 0 is 2, 1 0 0 is 4, 1 0 0 0 is 8. And you'll note that I'm not calling it 1000 or 100, because that's actually a little bit misleading. So we have this idea of 8 bits in this case, and you'll notice that the amount of digits under 128 equals 8. The maximum number that we can create out of this is 255. If I had all ones, I'd have 255. Now, an example of this in the actual technical use of bits would be 8-bit color depth. It has 255 possible colors if a decimal number is assigned to each color, because we can only count up to 255. So that's where that came from. Now, calculating decimal numbers, we have the 8-bit table. If you remember, it all goes up by 2, so it keeps doubling: 1, 2, 4, 8, 16, 32, 64, 128. This is an 8-bit system. These days we have 64-bit systems, so you'd have to keep doubling up until you get to the 64th number, and that will tell you the highest 64-bit number if you filled out all the ones underneath each section. So we have a binary number here, 10000010, and to work out the decimal value of that, we add where the 1 is on. So 128 has a 1, 64 doesn't, so we ignore it. And we ignore all the numbers that have a 0 underneath. 2 has a 1. So the decimal value shown here is 128 plus 2, which we know is 130. So 10000010 is 130 in decimal. And another example of this is here, where you've got 10101010. We have to add 128 to 32, which is 160, plus 8, which is 168, plus 2, which is 170. Now, you don't necessarily need to know how to do this, but this is just demonstrating why we're transferring these binary numbers around. So we're just going to do a quick conversion here. If I was to convert 10001 to decimal, I'd start at the 1 end, so we know there's a 1 under here. Then we go 3 zeros up and a 1 under the 16. So this one here is 17. Now if I was to convert 12 to binary, I have to look for what values I can fit into 12. So I know 8 can fit into 12, so I put a 1 under there. That means that we have 4 left. Now 4 fits into 4, so we put a 1 under there. I've got nothing left. So 12 is in fact 1100. That's just so you understand that aspect. Now, when we're converting bits to bytes, to megabytes or further, I've given some examples here. We've got 16 bits, which equals 2 bytes. So 16 bits is 16 divided by 8 bytes, which is 2 bytes. 2048 megabytes equals 2 gigabytes. We know that just from a basic idea, but the reality is 2048 megabytes is 2048 divided by 1024, and that gives us our gigabytes. 57,344 kilobytes equals 56 megabytes. And again, this is just a simple conversion of dividing by 1024. Now, what about this number? We have 117,440,512 kilobits, which equals, I think that's supposed to be megabytes actually, so sorry, not megabytes, gigabytes. Yes, so let's just quickly fix that. So to see the working for this, we'll go over to the next slide. So we have this amount of kilobits equals 14 gigabytes, and to get there, the first thing we're going to do is change the bits to bytes. So you'll notice it said kilobits. We need to divide by 8 to change to bytes. And you'll notice that it still says kilobytes, so I haven't actually transferred it into bytes on their own. We then divide by 1024 to get to our megabytes. Then we can divide this number by 1024 to get to our gigabytes. And really you can keep going dividing by 1024 until you can go no further, and you know that that would be the number that would be used. So in this case we had to stop here because it got to 14. Now some tips to doing this. Remember the bits to bytes conversions, so that was on slide 2. You can have a kilobit as opposed to a kilobyte, and it's really important that you understand the difference there, or a megabit as opposed to a megabyte. Now going from bits to bytes to kilobytes, etc. requires division, so 128 bits equals 128 divided by 8, which equals 16 bytes. Going from megabytes to kilobytes to bytes to bits requires multiplication. So we've got 128 megabytes, so I've times it by 1024 to get to my kilobytes, times it by 1024 to get to my bytes, and then times by 8 to get to my bits. You can see that's a rather large number just for 128 megabytes. So I'm hoping that sort of clarifies exactly how you calculate these numbers. These are the key points for most calculations in the industrial technology exam, because what will happen is they might give you resolution where you've got a color bit depth, or they might give you transfer speeds where you know how many bits per second, but the hard part of it will always be that kilobyte or kilobit or bit to byte conversion. And these are the things that you really need to remember. Hopefully that helps you.